Hello everybody, I hope you enjoyed this energetic presentation from Michael. I try to be equally energetic, but let's see. So I will focus on automotive lighting. Michael has mentioned a lot of other applications like decorative, signaling and other stuff, but I will want really to focus on lighting. Lighting means headlamps. It also means backup light, reversing and interior, but I want to focus on lighting. So, since not everybody knows who Focuslight is and what we are doing, I want to briefly introduce Focuslight. It was a fairly young company. It was founded in 2007 by our CEO Victor, and it's headquartered in Xi'an, where you find the Terracotta Army. It's a very nice place to visit. I can only recommend this. We have several sites in China and also since 2017 in Dortmund, Germany and Neuchâtel. And very recently we finalized the acquisition of passive optical components parts from AMS Austria, and we have a basis now in Singapore. Here are some key facts and figures. I don't want to read everything to you. You can take a look yourself. Roundabout we have 1,000 employees now, of which like 40 to 50% are outside of China. So we're a global company with a headquarters in China. Markets, we are serving diverse markets, which you can see here, health or also beauty, laser systems for skin treatment, for hair removal, and also for welding. A lot of business and optical communication, and also automotive, where I want to focus now. And our motto is to be the global business trusted photonic solution provider for your needs, and with a strong focus on innovation and fast response. So here are the automotive solution. We are supplying components for LiDAR, driver monitoring, HUD. So these are all optical components for scanning, for projection, for beam or light homogenization, and of course then for headlighting and for projections. I want to give you my view a little bit on why I believe that Microoptics has a strong future, not only in all the other mentioned applications before, but especially also for lighting. And I want to highlight four trends that are all going in the right direction for Microoptics. And these are the four trends that you see. We start with light sources. Very old slide here. You see the evolution of light sources. From the old fluorescent lamps over discharge lamps and so on. Finally, 2006 we started to see, or 2003-04 we started to see white LEDs, light sources which are substantially smaller, which enable optics to come much closer to the light source, and which in consequence enable to shrink the optics. Here's the consequence of that. So the old light source, an arc discharge bulb, very hot. You cannot get close to the light source, and the light source itself, the arc, is still relatively large. So you need huge optical elements to concentrate the light. In automotive lighting, we are always talking about strongly directional light with a vertical opening angle of like 10 degrees and a horizontal opening angle of like 40 degrees plus minus maximum. But most of the light is way more concentrated, and therefore we need large optics. With the introduction of LEDs here, that doesn't work, so you see the small dots over there. The optics became significantly smaller, even though the whole lamp is much larger than the previous one. With the conventional light source, each individual optical element has become a lot smaller. And now, as Michael also pointed out, we have even smaller light sources. So before we had millimeter type light sources, and now we're moving into micrometer range with 40 to 50 micron size sources. Here you can see some examples which are on the market already and which are already being used in cars. And when you now compare these light sources, you see that what is standard now in automotive lighting is light source sizes of 1 millimeter, maybe 0.7 in some cases, or going down to 0.5, 0.6 millimeter. And in order to concentrate the light, the optics that is needed has a certain relative size with respect to these light sources. Now if we go down to 40-50 micron, which are now the new automotive micro LED sources, obviously this opens a lot more options to make the optics smaller. If we even go further and would consider like the display micro LED light source sizes that are around, that are being developed of 5 micron, this would open yet another way, another order of magnitude for shrinking the size of the optics. Although, of course, today these display micro LED light sources are way less bright as required for automotive lighting. But think about it, we are still in the development of these light sources and we are not finished yet. So, especially even the current micro LED light sources for automotive could be shrunk to sizes. As you could see here, these are fairly large light sources, but they are only large because they have such a huge number of pixels. So if they had fewer pixels, they would become way smaller and would become compatible to micro-optical lights, micro-optical elements. This has already been explained previously, so we have always the problem to collimate the light, and when we shrink the optics, or otherwise, we try to enlarge the light source, we do not get the light where we actually want it to be. We just make it the light distribution wider, and this is a physical, and actually it's only geometrical fact. You cannot change that. So in order to make the optics smaller, you have to make the light source smaller. That is a strong trend that goes certainly in the right direction for us. Smaller light sources will enable smaller optical effects. Second is manufacturing. We are all here because we have something to do with micro-optics, either manufacturing micro-optics, making materials, making tools, metrology, other things to enable micro-optics. And yeah, this is now exemplary slide showing possibilities that we have within Focuslight, but taking more generally. This is really about the evolving micro-optical manufacturing system. We are all gaining more and more experience with fabrication of micro-optics, not only what you can see here, but also combining wafer. And wafer level is obviously a keyword. If you can do something wafer level, you are doing it in a highly parallel way, so you are making many optical elements at the same time, which could also contribute to reducing cost. And there are also many other applications like what has also been mentioned before by our friends from CSEM, photonic integrated circuits. There may be different manufacturing methods, but often the details are often related. For example, in metrology, these micro-optical elements have to be measured, and we are learning, we are improving. Manufacturing is certainly also a trend that supports the future of micro-optics. Yeah, this is now special to what we have in Switzerland, the typical imprint process. The third element is car styling. When we look at car styling today, we see that Unlike in the past, where you had big headlamps due to the large necessary size of the optical elements, we see that headlights, actually the lighting function becomes something that is kind of seemingly disliked by the OEMs. They kind of try to hide it very often, and they do the styling with thin lines, with thin lines of varying style, tilt, whatever you want, and do daytime running light with that, but they hide the headlight function. Yeah. Why do they hide the headlight function? Because the optical elements that are being used for the headlights today are large. They are way thicker, they are very frequently round, very few of them are slim, so apparently that's a style that's not really in fashion today. There are other elements, for example also pedestrian protection. You do simply not want huge headlamps in front of the car because the headlamp is quite sturdy. When you hit a headlamp with your knee, it's your knee that will be broken. When you hit maybe the softer bumper part, there is a chance that your knee survives. So that's also supporting the trend to making the headlamp smaller. So when you look at the evolution of car styling, you see this slimness, and this slimness can be best represented if you want to show the headlight by small optical elements. And in this case, on the upper right part, you see the realization with MLA. That is the lucid car that's on the road, and there will be further models coming from lucid having this lucid air. Now we see that lucid gravity hits the market, and there will be other models coming in the next few years. And so you see these two cars that where the headlamp is enabled. Very slim headlamps are enabled using micro-lens array technology. Both elements are around 50 to 60 millimeter high. You see that the one on the left is slightly elongated, while the right ones, that is actually almost a matrix because it's several elements in a row, is more or less square. And you can see the evolution of that, styling, enabling the previous model on the left and the new model on the right, which supports also the slim look and the smooth look of the car front in comparison to the tech look with large optical elements, with large projection lenses that was there previously. And finally, MLA performance. It's not so bad as you would think. We have now a reference design that uses 350 lumen per 1 millimeter square chip, and we achieve a full system efficiency of about 40%. Now that's without the outer glass cover, so that would be around 40% including this glass cover. So it's no longer the 15 or 20% numbers that may be in your head or that are being reported or that have been reported previously. You can do actually quite efficient system designs. Keep in mind, this is for an MLA that's just 17 millimeters high. You can do any degree of contrast that you like. We have actually found out we have way too much contrast. So that contrast is really scalable from very high to very low, and so it lends perfectly well also to the realization of ADB systems, which we are working on right now. So ADB with MLA is absolutely possible and is fantastic. Because we can do the ADB system in the same size factor as we have the module shown here, the low beam,
which is just, as I mentioned, is 17mm times 17mm, and actually most of it is most of the volume is taken by the heat sink. You see the comparison to the €1 coin. And this way we can enable very variable styling elements with these small modules. You can arrange them any way you like and realize different performance levels, different stylings. Also, in principle, it's possible to think about different shapes. Of course, one may wonder whether it makes sense to have different shape if the element is already so small. But it could also be embedded in a line-shaped DRL and would not need an extra space and would not need to be hidden beneath the DRL somewhere in the bumper. It could be very well be part of the daytime appearance of the car. With this, I want to conclude. Thank you very much. Summary you can see here. So these are the 4 trends again that support. In my opinion, our opinion, micro-optics has the future of automotive lighting, and by the way, not only automotive, there are also other applications in general lighting. Shrinkage of light sources, manufacturing excellence, styling trends, and the MLA performance. Thank you very much.